So let's look at some examples here. Write but do not evaluate an integral expression that gives the area of each of the following. So that just means we're going to set it up just like we were just doing, but we don't have to find a number, which is what evaluating means. So the area bounded by, that just means that there's a boundary. F of x, that's this. The x-axis, that's down here. And that's the line x equals 1 and x equals 2. So we're looking at this area right here. Now what we want to do is we want to cover this in little tiny infinitely thin rectangles, but to avoid having to draw them out over and over and over, we only have to draw one. However, we should pick how we draw that, such that if we did continue drawing them in both directions, we would always touch the same thing at the top and the same thing at the bottom. So for example, we don't want to draw them this way because we would be going from here to here for part of it, and then up here we would be touching this on one end and this on the other end. So the width down here is in the dx direction. So we're going to be doing an integral in terms of dx. We want to look at what's giving us the height of this rectangle. And the height of this rectangle is from the x-axis up to this line f of x. So the height of it is just whatever our x is. When we plug that into f of x, the number that we get. So the height is just f of x. We're starting, we want to say where's the first rectangle we would draw. That would be at 1. And the last rectangle we would draw, that would be at 2. What we can also do is we can plug in this because we know what f of x is. So we would say the integral from 1 to 2 of the square root of x plus 2 dx. And there's our answer. Sometimes, though, we're going to be working with multiple curves, like this one right here. It's saying we want to have the area bounded by f of x, that's this one, g of x, the line x equals 2, and the line x equals 3. So there's x equals 2, there's x equals 3, and then here's f of x, and here's g of x. Again, we want to draw our sample rectangle. So if I draw them like this, then I'm going to touch the same thing at the top and bottom all the time. This width here is dx. So I'm starting, my first rectangle's at 2, my last one's at 3. So we've got the integral from 2 to 3 with this dx. But how do we figure out the height? Well, we know that this number up here is going to be whatever g of x is, because this whole thing is g of x. And we know that g of x gives the distance from the x-axis all the way up to the top. This f of x here, this is going to give us the distance from f of x to the x-axis. So basically what's going on, this distance, that's g of x. This distance, that's f of x. And this distance right here is that we started off with g of x, and then we took away this little piece down here that we don't want. So the height that we're looking at here is g of x minus f of x. Or, since we know what g of x is, we can write this as the integral from 2 to 3. So g of x is negative x minus 2 squared plus 2.5. And then subtract whatever f of x is, x minus 3 squared plus 0.5 dx. So let's look at a similar one. This just says the area bounded by f of x and g of x. So it's not telling us to start at a particular number. It's just saying this whole thing, f of x, g of x. And we still have our same little representative rectangle. And it's still got the same dx. So we're still going to have our integral in terms of dx. And we've still got our top function, which is g of x. And then subtract our bottom function, which is f of x. But we don't know where our starting and our stopping rectangle would be. Because clearly we'd start over here. And since we don't know what it is, let's just call that A. And we'd stop over here, so let's just call that B. So in later lessons we're going to figure out how to find those numbers, but for now, let's just say it's going from A to B. Just like we did up here, we can substitute. And there we go. So this pattern that we see here is the same one that we're going to see in all the other ones. If we're trying to find the area bounded by two different functions, then when we're finding the height, it's just going to be the top function subtract the bottom function. So let's see, so this one's between when x is -1 and when x is 1. And it's bounded by g of x and f of x. So we can draw our rectangle. And we see that we're starting at -1. Or first rectangle's at -1, last rectangle is going to be at x equals +1. dx is our width. And then our height is just this top one, which in this case is f of x. Subtract this bottom one, which is g of x. Plug in the equations that we have. Voila. Here are some more examples. Still the same idea though. Bounded by just means enclosed by, so we've got g of x and h of x. Here's a sample rectangle. The infinitely thin width is in the x direction, so that's dx. Got the integral. This time we can actually see the number for our starting point. It's again at -1. We can actually see the number for our ending point. That's at 2, very convenient. Our width is dx. G of x here is on top during the section that we're trying to find, so we've got -x squared. Oh, let's write it out this way first. G of x minus h of x. And when we substitute that, g of x is -x squared plus 2. H of x is -x dx. Occasionally we run into one that's a little bit more complicated. So the area bounded by f of x, this is this, g of x, and the x-axis. So that's this area right here. But one of the things that we notice is that to draw rectangles, we have to draw them so that they're touching the same thing all the time. And right here, this is going from the x-axis to g of x. But at 1, it switches and starts going from the x-axis to f of x. Well, what am I going to do about it? One thing that I can do is I can divide this up so that I have two different areas here. This one over here is just between g of x and the x-axis. This one's just between f of x and the x-axis. So I can do two little expressions. One has a rectangle over here. One has a rectangle over here. They're both dx. And just like we've done in the past, I'm just going to add up those two areas. So my first one, why don't I do it in blue over here? Starting at 0, that's my first rectangle. My last rectangle's at 1. It is a dx. And I'm doing this top one, g of x, minus the x-axis, which is the function y equals 0. So I can do g of x minus 0 or just plain old g of x. And this is just ending on that x-axis there. Then to that I'm going to add this purple one. I'm starting at 1, ending at 2. The width is dx. So I'm taking f of x and I'm subtracting the x-axis, which is just y equals 0. So I can do f of x minus 0 or just f of x. And then go ahead and substitute those in. G of x is the square root of x. F of x is x minus 2. Be aware of ones like this. You do need to know your quadrants. So if we're talking about the area in the fourth quadrant, that's the area down here. So it's bounded by g of x and h of x, so it's bounded by this, and if it's in the fourth quadrant, it can't go up above here. So what we're going to do is we're going to draw our little rectangles. And once again, this part is going between the x-axis and h, and then this part over here, we see our rectangles going between g of x and h of x. So once again, we're going to need to have our two different pieces. I'm going to go ahead and do this one again in blue. But both of these are dx. So for this blue one, we don't know what this is, so I'm just going to call that a. It's whatever number that is there. We'll find it in later lessons. And I'm going to say that this first one, I can see that I'm starting at 0 and ending at whatever a is. It's a dx. And I'm going to take this top one and then subtract this bottom one. So this top line is just at y equals 0, so 0 minus h of x. And then to that I'm going to add, we're clearly going from whatever a is to 2. This one's on top, that's g of x. I'm going to subtract this one on the bottom, that's h of x. And it was a dx for the width. So, plugging those in, g of x is negative x squared plus 2 minus negative x dx. The same idea is right here. We want the area bounded by f of x, that's this curve, and g of x, that's that curve. But notice how there are two different areas. Over here, g of x is on top. Over here, f of x is on top. So I'm going to mark those in two different colors. So for the blue one, our first rectangle would be at negative 2. Our last one would be at 0. It's a dx. And since g of x is on top and f of x is on the bottom, my height is going to be g of x minus f of x. For the purple one, f of x is on top, g of x is on the bottom. So we're starting at 0, we're ending at 2. I'm going to do f of x minus g of x. When I plug those in, that will give us g of x is 3x cubed minus x squared minus 10x. Subtract all of fx, make sure it's in parentheses, negative x squared plus 2. This part is negative x squared plus 2, and then we're going to subtract this whole g of x, 3x cubed minus x squared minus 10x. And that width was dx. Looks kind of icky. For now, all we're going to worry about is writing it out.